This one is graded differently than other ones, and instead of a standard rubric, basically every question is worth a point. That's how you're graded. There are 10 questions. You can find them over here, questions 1 all the way down to 10. So it goes like this. Collecting a gas is tricky. It's not very easy. It moves very quickly. It's hard to contain, and it can move through other substances with ease. Measuring it is even trickier, especially if you need reliable measurements. You are going to be given a set of data that comes from an actual experiment that was done in my class about 3 years ago. You are basically then going to finish the lab. This is where the picture is going to go. It'll be there by the time you get it. I shared the procedure with you. You're not going to have to do any of this, but I started to give you the procedures because that way you have an idea of what that student actually did. There are pictures that they had, which shows the process of what they did. And then you have this. Now, I have been using this text caveat with a slightly dimmer coloring to signify that this is what the students wrote into the paper. So, this way, this is the data that you have. The video I mentioned earlier, it is about 7 minutes long. You really only need to watch 5 minutes of it. Goes over how this lab happens. It's a pretty good one. And then you have questions. I write the balanced chemical equation for the single replacement reaction. And if you read this, you've got magnesium, metal, and hydrochloric acid, which I believe it says in here. Yeah. So you've got that provided for you. Calculate the moles of magnesium based on mass. It's a very easy math question. Calculate the total pressure using the ideal gas law, which if you remember, the ideal gas law is PV equals nRT. So again, should be an easy question. Then you're going to use Dalton's law to calculate this. Be careful because the pressure here is given in millimeters of mercury, and you probably have it in ATMs. So I'm going to just write down a little hint that you may have to convert millimeters of mercury to ATMs. I'm just going to provide that for you. Because the thing is I don't intend this to be a hard one. But what's great about this lab is it basically goes over everything we do with gases kind of quickly and simply using a single reaction. I've actually used this to replace quizzes in my in-person class before when we didn't have time. So it's really a neat little thing where you get to do one of every gas problem we've done. Because then you get to do the combined gas law to determine the volume of gas that would have been collected at STP. And then you get to do a problem that has nothing to do with the earlier answers. So like 1 through 5, all of these questions are connected. In fact, I'm going to make a note to that just so that you'll see that. Questions 1 through number 5 are connected. So that way you know that those ones all are, they all are based on each other. So that's the big deal. And if you looked at the big word problem that I shared with you earlier and went over briefly last live class, if you can do that, you can do all of this. But this is all broken down into nice, easier steps. So like I said, I really love it. 6 is not connected at all. 6 is its own separate problem. And then 7 through 10 are all more thinky problems than mathy problems, if that makes any sense to you. They're concept questions, not necessarily math questions. You've got 3 errors here. You need to just determine if they're major or minor, and that's it. And then you're done. This whole lab should take you maybe 30 minutes to an hour and a half, especially if you work with your groups.